Sir,
Yes.
is this tutorial going to concentrate on 1.4 and 1.5?
I'm sorry.
Is this tutorial, is it going to concentrate on 1.4 and 1.5?
So in this tutorial, we will be covering only exercise 1.3. So let's just wait for a few minutes so that everyone can join, or most of us can join. So let's give it 3 more minutes.
Does anyone know if the professor said to finish up to chapters 1.5? Because I remember him saying that, but then online he doesn't have the uh, the PowerPoints up to 1.5. They finish at 1.4.
He told us to read 1.4 and 1.5.
Yeah, okay. I guess we have to do 1.5 from the textbook then, because he doesn't have PowerPoints up yet for that.
Wait, have you read 1.4?
1.4, yeah, I did the rest of it. I don't know, I guess this tutorial we're only doing 1.3 questions. I don't know.
Okay, guys, let's start. So first of all, is everyone able to hear me?
Yes.
Okay, great.
Yeah.
So again, this is the second tutorial of your tutorial section 2. And then there is another tutorial section, so tutorial section 3. So the questions covered in both the tutorials are different. So if anyone wants to cover more questions, so they can just watch the other tutorial section as well. So both of the tutorials are on the Moodle and as well as on the Microsoft Stream.
Are they covering different sections, or are they just going to do the even and odd, like you do even and the other one does odd?
Yeah, basically, so they are covering different numbers, right? So
But the
so
same section, right?
it's the same section, but
Okay.
we will be covering different questions, right? So if anyone wants to get a practice of a lot more questions, so they can just watch different tutorials and they can get used to it. Okay. So okay, so I think most of us are here. So let's start. So today we're gonna be covering exercise 1.3 of your textbook, and let's start with the first question. Okay. 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 So is everyone able to see the screen?
Yes.
Okay. So our first question is the question number 1. So these are the exercises from exercise 1.3 of your book, page number 38. So if anyone wants to use this for the reference, they may. Okay. So let's start. So the first question is to have a truth table to verify these equivalences. So again, so this P here, so this is a propositional symbol, and then T here signifies that this is a truth value. And then this P here is the same as this one, and then this symbol is for the logical equivalence. So we have to make a truth table, and we have to prove that this is basically the left hand side is equal to the right hand side by using the truth table. So let's say for P, and then we have this truth symbol here. Okay, so for P, there are two values since it's a propositional symbol. So it can either be true or it can either be false, right?
Yes.
And then for the truth over here, so there is no other possibility other than it being the truth value itself. So true and true. And then we have to, so if we AND them together, so P and truth value, so what's going to be the value of this? So when it's true, and then we AND it with a true as well. So it's going to be a true. And then when it's false, and then we AND false with a true, it's going to be a false. So it is true and false. Okay. Let me know if there are any questions. Otherwise, we can proceed forward. So moving on to the part C, we have P and with false. And then we have P and false. So likewise for P, we have two possibilities. It can either be true or false. And then for false, it is always false. It cannot be true. So when I AND the truth and false, so it's going to be false. And then when I AND false and false, it is also false. So here, the result of this false false is basically equal to this false, right? So this false truth values are these. And then P and F, this compound proposition truth values are these, and they are equivalent to each other. So we proved using the truth table that they are equivalent. moving forward. So this is part number E. So P, we have P, and then we have P as well. So this P is coming here, and then this P is coming here. So because it's going to be the same truth value, so I'm not writing here 2 times. So in fact, I can write P or, let me get the symbol. So P or P, and then we can, so for P, we have true or false. Here, the order doesn't matter. So you can either put false on top or true on the bottom. So it's up to you. And then once you, or this symbol is also called disjunction. So once you do or with itself, so true or true is true, false or false is false. False. And then we know that this true, false, the value of this compound proposition P or P is equal to P itself. So using the truth table, we proved that they are logically equivalent to each other. So are there any questions? Okay, no question, we can move forward. Okay, so the next question we have is the question number 3, and then we have to use the truth table to verify the commutative law. The commutative law is over on this side, so P or Q is logically equivalent to Q or P or over here. Okay, so these are the commutative laws, part A and part B. So using the truth table, we will prove these are actually correct. So let's use this. So we have P, and then we have Q here.
Using the small q.
Yeah, sorry, let me just get one more column table. Okay, so here we have P, Q, and then we have P or, take the symbol from here, P or Q, and then we have Q or P. Okay, so yeah, just remember that these symbols are just the same as this one. Okay, so it's auto capitalizing it, but these ones are exactly the same as here. Okay, so now what
They're
are,
all lowercase p and q.
yes, they are all the lowercase letters. Okay. So now for P, the truth values it can take is true, true, false, false. And then for Q, it can take true, false, true, false, so that we cover all the possible cases, okay, for P and Q. Okay, so now if we take the disjunction of P or Q, so true, true is true, true, false is true, false, true is true, and then false, false is false. Now we have simplified the left-hand side of this equation, which is P or Q. We know the truth values of this is here. Now Q or P, so we or Q or P. So we say true or true, it's going to be true. And then we have this false or true, it is true. Then true over here or false over here. So it's going to be true as well. And then lastly, false or false, it's going to be false. False. Okay. So here, this is the left-hand side of the equation, and then this one is the right-hand side, and then they are both equal. We can see from the truth values. So in disjunction, the order doesn't matter. You can either put P or Q, or you can either say Q or P. So you can use them alternatively. Okay, so let's do this one as well. So here, okay, so we have P, and then we have Q, we have P, we have and P and Q, we have Q, Q and P. Okay. So likewise, the possibilities are true, true, false, false. Here it could be true, false, true, false. Okay. So now we take the conjunction of P and Q. So this true here with this true here is going to be true. Now here, true and false, the conjunction of true and false is false. So now this false here with this true is false, and then this false is going to be false as well. Okay. Now we have this Q and P. So this Q here, the true, and this true, so it's going to be true. Now this is going to be false, and this true, it's going to be false. This true over here with this false over here, it's going to be false. This false over here with this false over here, it's going to be false. Now here, this right-hand side of the equation here is equals to the left-hand side of the equation here. So we know that they are logically equivalent, and also the order doesn't matter. Okay, so you can either replace them with one another. Okay, any questions here?
No.
Okay. Nope. That's great. You guys are learning. Okay, so now we have this big equation, and then we have to prove that this distributive law here. So distributive law here, or if you can see on the left hand side of the screen, so this on the bottom is the distributive law. So basically what it says is we have to prove that the left hand side equals the right hand side. So we take them here. Okay, so we take P
And Q and R.
Why does it Q, and then R, and then we have Q or R. Q or R, and then we have P
And Q and R.
Q or R. Okay, and then we can put this P and Q here, or maybe, so let's only do the left hand side, and then we're gonna do the right hand side of the equation. Okay, so let's do here. So P here, it's gonna be true, 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 false, 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 false. And then it's gonna be true, true, false, false, true, true, false, then false. Here we have true, false, true, false, true, false, true, false. Okay, so now, so we have this Q over here, and then we have to OR it with this R. So true or true is true. True or false is true. False or false or true is also true. False or false is false. True or true is true. True or false is true. False or true is true. And then false or false is false here. Okay, so now we have this Q or R over here. So we need this Q or R in the next step, and then we have this P. So this P here, and then this Q or R, we have to do the disjunction, the conjunction of these two. Okay, so we take true over here and true over here. It's gonna be true over here, and then so true over here is true, true over here, and true over here is true. So we have true over here and false over here. So it's going to be false. So false, true is false. False, true is false. False, true is false. And false, true is false. So we have this here. So the left-hand side is the result of this. The truth values are here. Now we can do similarly the right-hand side as well. So let me just get the table and
Can't you do it in the same table?
then I will have to insert. So, okay, maybe I can try because I just want to put this out.
Insert one more column. Yes, or two more columns.
Try that. I think there is there a way to insert new column in here? Yep, insert column to the right. Okay. Okay, we have enough column, but we don't need this much column. So let's undo this. Insert. That's a lot more columns.
You can delete the last three. Delete column.
Okay, let's try that. Okay, so maybe let's continue with this one over here as it is. Maybe let me enlarge. But you guys are able to see clearly, right?
Yep.
Yep.
Okay, so we have the P and Q over here. So P and Q over here, and then we have this P and R over here, and then we have this P and Q, P and Q. Then there is a conjunction, but
Or. It's or. Put an end there.
P and R. Okay.
The other one, or.
So over here?
Oh, second.
After
the bracket. Bracket.
Oh,
The middle.
Here. Okay.
Middle.
Symbol. Okay.
Yeah.
Okay. Here. So we have this P and Q. So we like so true and true is going to be true. True, and then we have this true and true. It's going to be true again. True and false. It's going to be false. True, false is false. False, true is false. False, false, false. And then now we have this P and R over here. So this P and then this R over here. So true and true. It's going to be true. True and true. It's going to be true. True, false is false. False, 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 false. Over.
Miss, the second row for P and R, isn't it false? I think it's false. True and
Sorry?
true. The second row for P and R.
P and R, the second row.
Yeah, I think it's
That's right.
false.
Yeah,
Or
that's right.
minus.
And this is going to be true. Okay.
Yeah.
Okay. Okay. So now we have these two over here, and then we have to OR them. So this is true and true. It's going to be true. This is going to be true. This is going to be true. And the rest will be false. So now, according to the distributive law, so this left-hand side should be equal to the right-hand side. So we have the truth values of the left-hand side over here and the right-hand side over here. And then we know these truth values are equivalent to each other. So therefore, we say that they are logically equal to each other. Any questions here?
No.
Okay, great. Okay, moving onwards. So we have this question over here. So we have to use the De Morgan's law to find the negation of each of the following statements. So we have some statements over here, and then we have to find the negation of these statements using De Morgan's law. So let's take the number first statement. So here it says that Jen is rich and happy. So in this statement over here,
Hello? Yes. Sorry.
okay. So in this statement over here, we have Jan is rich and happy. So now we have two variables over here. So Jan is rich and the other one is Jan is happy. So let's say P here represents Jan is rich. And then Q here represents that Jan is happy. And in order to represent this statement, Jan is rich and happy. So the statement will become P and Q. Okay. Now, in order to apply the De Morgan's law here on the left-hand side, so P and Q, we have to take the negation. So in order to take the negation of this one, so the symbol over here. So in order to take the negation of P and Q, so this is going to be equivalent to negation of P or negation of Q. So negation of P or negation of Q would be. So we have negation of P or negation of Q, right? So now we just replace these P and Q with the word. So negation of.
Isn't that supposed to be and? It says Jan is rich and happy.
Yeah, but if you see the statement over here, so it says here, so when it's and, when you apply to De Morgan's law,
Oh, okay.
Or. Okay.
It's the same as that. Okay.
Okay, so we say here, we have the negation on the, so we have this Jan is rich, then we have this or Jan is happy, and then we just put the negation, we put the negation over here. So this statement over here, it becomes equivalent to Jan is not rich or Jan is not happy.
Miss.
Yes.
Can you also write John is not rich nor happy?
Yes, exactly. So just like we proved here that ordering doesn't matter, right? So we can either replace P or Q with Q or P, right? So let's say this is Jan is rich and this is Jan is happy. So we can just reverse the order. So because it's the Q, this is the commutative law. You guys should be familiar with this. So this is a very important slide on the left-hand side. So whenever we have an or, the ordering can be switched. So one thing can on the left hand side can be replaced with the right hand side. Okay, so this statement can be also Jan is happy or Jan is not rich. Okay, but because they were like P was on the left hand side first, so that's why I put this here, but you can put the other way around. Okay. Okay, let's do part number C here. Part number C says my walks or takes the bus to class. Okay, so this is part number C, and then let's represent them using the letters. So let's say P represents my walks to the class, and then letter Q represents letter Q. Q represents my takes bus to the class. Okay, so we have to say P. If we represent this statement, my walks or take the bus to class using the propositional logic, we will be saying P or Q, right? Okay, so we have this P or Q representing the statement over here. Now we want to negate this statement. We want to negate the statement using the De Morgan's law. Using the De Morgan's law, we have to negate the statement. So here, the De Morgan's law. Now we will be using the underneath equation. So here it becomes this negation of P.
Walks to the class.
Yes, the negation of P, and then we have this negation and negation of Q. Okay, then remove the bracket. With the bracket, the same thing. Okay. So we have this. Now if we replace this with the word, so my walks to the class and negation of, let me just put it on the second line here, and my takes the bus to the class. Is basically equivalent to my is not walks to the class and does not take the bus to the class. Okay, so using the De Morgan's law here, we prove that the negation of these statements using propositional logic. Okay, questions?
Are you going to be posting this on the Moodle?
Yeah, actually, the tutorial was already up online. So was anyone able to see the tutorial online?
Yeah.
Okay, great. Okay, so yeah, so I will also try to upload this to the Moodle or on Microsoft Stream. Okay. Any questions? Okay, if not, let's move to the next question. Here. Okay, so here are these questions here. Okay, so for each of these compound propositions, use the conditional disjunction equivalences, example 3. to find an equivalent compound proposition that does not involve conditional. Basically, what we have to do here, so we have to use some of the equivalences here. So on the left hand side, if you see, there are some equivalences. We have to use those and we have to simplify these statements over here. So here, let's start with the part A. So P or negation of Q. So here we have P, and then we have R, negation of Q. Okay. So now, I'm sorry, it's implication, not R. So P implies negation of Q. Negation of Q. So this one, the rule that we will be using is over
The more logical equivalence.
yeah. So here, if you see P implies Q is logically equivalent to, so negation of P or Q is equivalent to P implies Q. So this statement over here can be also written as this, negation of P or Q. So if I have to convert this statement into that using that rule, this rule, logical equivalence, so this becomes negation of P, and then this becomes or, here negation, and then, sorry.
Double negation.
Okay. So it becomes negation of P or negation of Q. Okay. So we just applied this rule that P implies Q is logically equivalent to negation of P or Q. So we make this negation, we replace this with or and with this negation, and then the rest stays the same. Okay, so this is logically equivalent to this thing.
Since we can't remember all these identities, what do you suggest that we print and keep for reference when we're doing these exams? Because it's impossible to remember all of them.
No, it's actually not going to be impossible, and there are not going to be too many. So if you will see over here, like for example, this identity, right? So there are two ways to remember. Either you memorize this, or either what you do is you can just prove this using the truth table. Or once you do some questions, you will probably get used to it. Like once you came to some question which requires P conjunction true, then you will know that it is actually equivalent to P. It just takes a couple of exercises and then you will be master at it. It's not going to be too hard.
Okay, what about online questions? Like those work too, right?
What about which questions?
The questions online that involves proofs.
Yes, so the question that involves proof. So for example, here we are also, we have another question of proving, right? So we're going to be doing that. So using those equivalences. So these are very important, and I think you need to memorize these. So for example, these laws, some of the laws you have to memorize, and then
Is it all of them, right?
I'm sorry?
All of them, right?
Well, they are all important. So try to memorize as much as you can.
Okay.
Yeah, try to memorize as much as you can, and yeah, but these ones are important and you will definitely need them in the questions. Okay, moving onwards. So let's take part number B here. So P implies Q. So P implies Q implies R. So then there are brackets here, implies R. Okay. Now let me just, okay. So here we're using the same rule. Let me just write it down here actually. P implies Q is logically equivalent to negation of P or R. Sorry, Q. P or Q. Okay. Now we have to apply this rule over here. Okay. So if we apply this rule here, so in the brackets, I'm going to put the brackets. I'm going to write it as negation of P or Q.
This is good.
Okay, and then I just write down the rest of the equation the same way. Okay. Now we have this one more implication which we can further reduce using this law. So what we do is we treat this whole compound proposition as if this is P, and then this implication, and then this R, we can assume this is Q. Okay, so we just do this. So negation of this whole thing, negation of P or Q, right? And then we do or R. Okay.
Okay. So precedence matters in proofs, right?
Yes, exactly. So if you guys remember in the last tutorial, we had an order of precedence. I just have a brief lecture on that as well. So basically, the one in the bracket, they need to be resolved first. Okay, so that's the precedence. Otherwise, you won't be able to reach to the correct solution. You need to memorize the precedence. Okay, so the ones that are in the bracket, they needs to be solved. If they cannot be solved, then we take the precedence order. Okay, for example, here we have negation, or we have this disjunction. Based on the precedence table, what do? We do the negation first, because the inner propositional statement cannot be further resolved. Okay, so here we have, so this negation P or Q, if we treat this as over here, we can apply the De Morgan's law over here. So negation P, and then there is something inside over here, and then it becomes, so whenever there is negation outside, this sign over here becomes the opposite. So negation or becomes the and sign. So let's do this. So negation, let's apply the De Morgan's law. So negation of P, right? And then this or becomes and this becomes negation of Q. Okay, and then we have or R here. Okay.
So that just becomes P.
So negation and negation of something is becomes P itself, and then this becomes and negation of Q or R. So this is going to be the solution. So this thing over here is logically equivalent to this thing, this thing, this thing, this thing. But this is the most simplified thing we can ever reach with this statement. Okay, so you can replace the statement with any of these ones because they are logically equivalent, and then you can also prove those using a truth table as well. Okay, questions? No questions. Let's take another.
So if you didn't have the identities, if you didn't remember the identities, you would do this by using the truth table method.
Yeah, if you don't remember the identities, then you can of course use the truth table, but then again, it's gonna be taking you a lot of time using the truth table. So, but I don't think like it's too hard to remember, because once you just start like practicing some of them, then it's gonna be like in your memory. Okay, no questions. Let's move forward. Okay, so let's take a last example. So negation of Q. So we have negation of Q implies P here. Negation of Q implies P implies P implies negation Q implies P implies negation of
Q.
Q. Okay, so this is what we have here. Now, again, if you see there are three implications inside, and we can reduce them using this rule over here. So let's apply this rule over here. So in the bracket, so if we replace this, so this becomes negation of Q, and then this sign gets replaced by or, and then this becomes here P. Okay, and then the rest will follow. Okay, so it's gonna follow over here. Okay, now we apply negation, and negation is Q or P. Then we have this P implies negation of Q. Now we have we're gonna apply this same rule over inside over here, right? So this rule over here, so it's gonna be the same on the left hand side, and then here we will say negation of P or negation of Q. Okay, now let me just write it down here. So Q or P implies negation of P or negation of Q. Okay, let's continue here. So now in order to resolve this, so we have one more implication here, which we can reduce using the same rule here. Okay, so we can say that this is equivalent to negation of Q or P, and then we have this or again. We say negation of P or negation of Q. Okay. Now we have applied the De Morgan's law. And we will be applying the De Morgan's law on this side, on this compound proposition. So it's going to be negation of Q, and then this R will become and it's going to be negation of P. It's going to become or negation of P or negation of Q.
Yeah. Can it still be broken down?
I'm sorry?
Can it still be broken down from this? Or this, because in the textbook I saw the answer was negation of P or negation of Q, and I was wondering how they got it.
Yeah, we have not yet reached the answer. Okay, just bear with me, and then we can simplify this further down. Okay, I'm just telling you the steps. So initially I'll be doing like in a very detailed way, but later on I might not go in such details because we have even more complex problems. Okay. Okay, so we simplify this down to this thing here. Now we have this negation Q here, and then we have this negation Q here. So let's put them together, negation Q or negation of Q. Okay, so this Q over here, and then this Q over here. And then we have this and over here, we put this. We have this negation of P, and then this or. This negation of P.
So you just switch the terms like you do in algebra, right? When you're adding and subtracting.
Yeah. So
is that allowed? Like you could just switch terms if you want to when it comes to ands and ors.
yeah. So when there is nothing like that can be broken down into more smaller pieces, you can, like for example here, there is nothing that can be solved inside, right?
Right.
So what we can do is we can just take this out and then we can switch them around.
All right. Okay. Thank you.
Okay. So now we have this negation Q or negation Q. And then according to some rules over here, so if we have negation, so this statement over here, negation of Q or negation of Q, it is equals to negation of Q itself, right? So this is according to this law. When you have P or P, it is equivalent to itself, right? So this negation of Q or negation of Q is negation of Q itself. Okay, and then we have this and here, and then the same thing, so it becomes negation of P or negation of P. So it's negation of P or negation of P, it equivalent to itself.
So the rules, they can apply to different but similar forms, right? Like now that negation of P and negation of P. Although it is different from the original one, the law still applies to it, right?
I'm sorry, the voice is cutting off.
So that negation of P and negation of P, right?
Yes, here.
Although it is different from the original one, original one, it still applies to it, right?
Yeah, basically what I did is, so if you see this statement, this compound proposition over here with this one over here, they are similar. So I consider this as P, right?
Yeah.
And then I consider this as P. And then there is or sign in between, right? So P or P, it becomes P or P. If you see here, this statement over here, idempotent law, P or P is logically equivalent to itself, right? So you have to use these analogies in order to solve out these problems. That's why the rules are very important. Of course, you can use the truth table to reach some conclusion as well. Okay, so here you will use this as well. Okay, so and here I did the same. So I consider this as P, and then consider this. So this is equivalent to P, right? So P I consider as negation Q. So I just replace it with negation Q here. Okay, which was my P. Okay. So you have to try to find a way to make your equation look similar to some of the rules or equivalencies here so that you can apply them and simplify your equation. Okay. And then if we want, what we can do is we can further apply the De Morgan's law on this one, negation of Q and negation of P. So if we go here, so if we have negation of P and Q and negation of P, so there are two negations and then there is and between, we can write it like this, negation of P or Q. Okay, so we can write it as negation of, we consider this as P and we consider this as Q. So we can write negation of P, which is our negation of, which is our Q, and then or it's going to be this P.
Right.
Okay, because if we open this up, it's going to be like this, a negation of Q and negation of P. Okay, so this is going to be the simplified answer, although this answer can be expressed in different ways as well. So for example, this statement over here can be expressed as this way as well. This is of course a simplified way of saying this, or this or this, but if you want to say like the most simplified way, then this is going to be the simplified way. Okay, questions? Everyone understand everything? Okay. Let's move forward if everyone understand. Okay. Now, so this one is solved. Now, let's move on to the next question here. Okay, so here we have to show that these statements are tautology by using the truth tables. So here, so basically what a tautology is, which simplifies to all the truth values. So if anything that has false or truth inside, that's not a tautology. So it has to be, so for example here, it has, so this is the true, this is the false, this is true. So in order to make this a tautology, all these true should be the truth values of and the only possibility for this conditional statement. Okay, So let's start with the problem number A. So we have this P, and then we have this Q, and then we have this P and Q, and then we can add more table columns on the side. So it's going to be P and Q implies P. Okay. This bracket over here signifies that you should solve this first. Okay, so brackets always take the precedent. Okay, so here we have two variables here. So two variables, P and Q only. So the number of possibilities are 4. So 2 to the power of 2 is 4. Right, so two variables, 4 possibilities. So we say true, true, false, false, true, false, true, false. Okay, so we have P and Q. So if we take P conjunction with Q, so true, true is true. True, false, 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 true, false, 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 false. Okay, now we have to imply the use the implication over here. Now, in order to use the implication, so we will be using the truth table as well.
True.
Okay, so here we have
True.
the first one will be true. So here, this true over here with this implies this true over here. So true implies true is true. This false over here implies this true over here is true. Likewise, this false over here, but this false here, it's going to be true. And then false, false is true. Okay, again, using the truth tables of the implications and conjunction, we simplified this and we found out that it is a tautology. Okay.
P and Q is false, and then you have a true P, you still get a true?
P and Q is false, and then this is true. So yeah, so basically in the implication table, the order matters. So this here is false, implying a truth. Right? It's not like truth implying a false. If it is truth implying a false, then this is false. Okay, so when it's, for example, if this is the other way around, so P is here and then P and Q is over here, then it's going to be false. But it is the false implying a truth, then it's going to be a truth. Okay, so again, just using the truth table. So if you have a truth table on the side, so again, here you will have to memorize these equivalencies and truth table. They are very important. Okay, if no question, let's take another example. So here we have negation of P. Take the symbol negation of P, and then we have here P implies Q. Oh, sorry, should be. Let's first take P. Let's take Q. Let's take negation of P. Let's take P implies Q. P implies Q. Let's add some rows. And then we have this negation P implies Q. Okay, let me just lower the text. Okay. So let's solve this. So again, there are 4 possibilities, 2 variables. So true, true, false, false, true, false. It's going to be true, and then it's going to be false. Now, negation of this, so it's going to be false, false, true, true. Okay. We have this P over here, and then we have this Q over here, right? So we say true, false, true, false, true, true. Okay. Now we have this over here, implying this thing over here, right? So false implying a truth, just like we saw here, over here, it says truth. False, false as truth. True, true is going to be true. And true, true is going to be true as well. Okay. So we saw that this is also another tautology. Questions? Let's take the last example. Negation. Negation P Q P. So this is part number E we're doing. So here, so P Q. We have P implies Q. We have negation of P implies Q. We have this thing over here implies P. Okay. Now we have to prove that this over here is a tautology. Okay, so let's solve true, true, false, false, true, false, true, false. P implies Q. So just like we saw here, it's gonna be true, false, true, true. Okay, we take the negation of this, it's gonna be false, true, false, false. Now we have this thing over here implies this thing over here. False implying a truth is a true. True implying a truth implying a false over here. Sorry, this truth implying a truth over here, right? It's gonna be a truth. False implying false over here is true. False over here implying false over here is true again. Okay. So we have also proved that this is a tautology. Okay. Likewise, we can prove that all of these are the tautology. Okay. Questions? Okay, if no questions, then let's move forward. Let's take question number 15. So we have this. Okay, so we are saying okay. Okay, so there we are here. We are using the exercise 11 question, and then instead of using the truth table, we will have to prove them using the logical equivalencies that we did over here. Okay, so let's take exercise 11 and here. Okay, let's take this first part A, and then we have to prove that this is a tautology, not using the truth table, but by using the logical equivalences, these ones. Okay. Let's say P, let's do part number A. Part A, P and Q implies P. P and Q implies P. Okay. Now we have here implication again. We can reduce it down, use this again. So negation of this part, consider this part as P. Okay, consider this as P. So negation of this whole part, P and Q, this statement over here, and or this P. Okay, now we apply the De Morgan's law. De Morgan's law is over here. So negation of this stuff is negation of P or negation of Q. So negation of P or Q is negation of P or negation of Q. Then we have this or P or here as well. Okay. So because now we can order them up because they have the same level of precedence. Okay, and then according to these equivalencies, we can switch them around. So because P and P are similar, we're going to put them together because we can solve them. Negation of P or P, then we have or negation of Q here. Okay. So here negation of P or P, this statement over here, we can use this. Negation of P or P is logically equivalent to true. Okay, so we're gonna say true or negation of Q. Okay, now this statement here, if we consider it as P, then our equation, we consider this as P, then this equation, the resulting equation will become similar to this, and then we can simplify this, right? So P or T is logically equivalent to T here. So therefore, T or P is logically equivalent to truth value over here.
Yeah.
Okay, so basically the trick is to make these statements equivalent to or look in some way equivalent to these forms so that we can replace them. Questions? Okay, let's take the part number C. So we have, let's put this on the side. Okay, part number C. It says negation of P, negation of P implies P implies Q. P implies Q. Right? Okay. So let's first resolve the implication. So implication P implies Q. Let's put it down in this way. Negation of P or Q. Okay, so we have one more implication. So it's a negation of, so this here, this becomes P, and then this whole thing becomes Q. We have to make this equivalent to this form, okay, so that we can resolve it like this. So negation of P, and then this becomes R. This stuff will just follow. Negation is going to be P or negation of P or Q. Okay, let's remove the bracket because nothing can be further solved in the bracket. Or Q. So here we have this P or negation of P, right? Just like we have here. We know that this is true. True or Q. Okay. Now this true or something is true or something is always true.
It's true. Yeah.
The symbol doesn't have to be the same. Okay. So true or something is true. So here this is true again. So using these equivalences, we prove that this is a tautology. Questions? Okay, this will last one. Okay, let's do part number E. It says negation of P implies Q. So negation of P implies Q. And then we have negation of P. Okay, so negation of P implies Q implies P. Okay. Okay, so just like any other we have done, let's just first replace those implication signs. So negation of P or Q implies P. Now negation. Okay. Let's first do the negation here because this has more precedence than this implication sign. Okay, let's do this. So negation. So we will be applying the De Morgan's law. Okay, like here. Negation of P or Q. Something inside is or. So this one. Okay. So negation of P then this or will become and then this negation multiplied with this as well. We have this implication, then P. Okay. So here negation is P and negation of Q implies P. Okay. Now we have to remove this implication again with this. So negation of this thing P and negation of Q or P. Okay, applying De Morgan's laws once again. Negation going to be negation of P. This and becomes or. Negation Q or P. This becomes negation P or negation becomes Q or P. Here, because we don't have anything further to solve, we can just take out the brackets. Negation of P or Q or P. Let's reorder them. Negation of P or P or Q. Now this thing over here, we know that this is a true. So true or Q. Anything or with the true is, like we saw here, is
True.
Okay, so this is how you can solve the propositional logic using those equivalences instead of the truth table. Questions? No questions? Okay, let's do one more if there is no question. So now we will be solving this using the truth table as well. Let's insert a table. Okay, we have P, we have Q, we have P and Q, we have P ORed with, where's the R symbol? P ORed with P and Q. So here we have true, true, false, false. Gonna be true, false, true, false. P and Q, it's gonna be true and true is true, false, false, false. P or, so this thing here is ORed with this thing. So true, true is true. True, false is true. False, false is false. False, false is false. Right? And then this, the resulting truth values again here matches with the truth values of here, right? So we know that therefore this left hand side truth values, because it matched with the right hand side truth values, so we know that these ones are equivalent. So you prove this using the truth table. Okay, let's do one more. We have P, Q, P or Q, and then we have P or Q, P and, okay, that's true, true, false, false, Q, true, false, true, false. Now this P or Q here is going to be true, 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 it's going to be false. This thing here, and with this thing, so true, 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 false, 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 true, false, 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 false. Okay, so this thing here matches with this things over here. So we know that these two are equals to one another, and this is a proof of absorption law here using the truth table. Okay. Questions? Okay. If no questions, let's move to another question. It's going to be question number 19. So here we are asked to determine if this is a tautology or not. We can either do it using the truth table, or we can use the logical equivalences to prove this. So let's do this using the equivalences so that you guys understand how to use the equivalences better. Okay, so if you guys have taken note of this, we can just remove this. Okay, so the question is negation of Q. Negation of Q. Q. Negation of Q and P implies Q. Implies negation of Q. Negation of P, sorry. So negation of Q and P implies Q implies negation of P. So it's very important to write down the question exactly how it is, because otherwise you might find a wrong answer at the end and you realize at the end that the question is wrong. Okay. So again, let's start to do it on the basis of preferences. Let's solve this inner ones first. So negation of Q and P implies Q using this rule. Negation of P or Q implies negation of P. Okay. So now we have this negation of Q and negation of P or Q. Now here, we have to take note of one thing is that we have this and here, and then inside this is or. So we cannot just use it, open the brackets up like this. Here, if we have this statement over here, so yeah, this one here. So the first one, so we're gonna be using the distributive laws. We have or on the outside and then and in the inside. Okay, so like just like here, it should be this one. Actually, it should be this one because and is on the outside and or is on the inside. So we're gonna open it up like this. Okay, so this negation Q will be multiplied by both. Okay, so let's put it like this: negation of Q or negation of P. I'm gonna put them in the bracket. This here is gonna be and because of this and here, it's gonna be or and negation of Q and negation of we already did with P, right? So it's gonna be negation of Q and this
Q.
here itself. Okay.
Yeah.
And we will write negation of P on the inside. Okay. So this was the major trick here. Okay, so remember, whenever we have opposite signs on the inside and outside, we use the distributive law to open them up like this. So we use here the one at the bottom. So and on the outside or on the inside, we put the ands inside and or outside. So we put the and inside and or outside. Okay. Now we can just remove the brackets in the next step, and then I can just take it out in the next step like this. Okay. Just to simplify them because there is nothing inside we can solve them. So we just take out the bracket. Okay, now let's put them together because we have a negation of Q, negation of Q, negation of Q, Q. So let's simplify this first. Or we can simplify this negation of or with negation of, negation of Q with negation of Q. We can do either. So let's do this one with this one. Negation of Q or negation of Q and negation of P and Q. Okay, then implies negation of P. So we, if we consider this as P, so this thing here as P, and because this thing over here is just the same thing as we assumed, and we assumed this as P, so it's going to be P as well. So we know that P or P is P itself, right? So which is negation of Q. Negation of P and Q. It's going to follow So here again, negation of P, and we have Q here. Negation of Q and Q, right? So negation of Q and Q and negation of P, and the rest follows. So we have negation of Q. So if we can, so here, let's see which rule we can apply from here. Okay. Here, so when we have something and with the opposite of itself, so something and with the opposite of itself, it's a false. Okay. So P and negation of P is false. So we can write this here as false, right? False and negation of P, right? And then this is implies negation of P. Okay, now we have to simplify this implication. So what we do is we take the negation of this thing here. So negation of false and negation of P, or negation of P. Okay. Now let's open up this using the De Morgan's law. We simplify this. So negation of false becomes true, right? This becomes or when we open it up, and then negation of P becomes P. So negation of P or negation of P. Okay, so we have this true here. We have this or, don't forget the brackets. Negation of negation becomes P or negation of P. Okay. Now because we don't have anything further we can solve inside the bracket, so let's take out the bracket. Okay. So true or P or negation of P. Now there's this one statement inside that we can solve, right? So with this, we know that P or negation of P here, P or negation of P is logically equivalent to true, okay? So we say true or true. When something is true or with true, it's the result is also true. So we proved using logical equivalences that this statement compound proposition here is a tautology.
Yes.
I have a question.
I did it another way. Can you, let's say
Questions?
you've done the, I think
Just one question I have. In the fourth line where there's a negation Q or negation
Any
Q,
questions you guys might have?
Yeah, I have one question. How did the disjunction of negation Q and the negation Q came out when you were doing from line 4? That's what I wanted to know. Where did the negation the disjunction came from?
No questions?
Yeah, I have a question. In the fourth line, how did you get the disjunction for the not Q or not Q? How did you know like that was the disjunction there? For the fourth line of that question 19, how did you know like the disjunction for the fourth line? That's what I want to know.
So 1, 2, 3, 4th here.
Yeah. How did you know that the disjunction was for for that line? How did you get the disjunction for not Q or not Q when you were switching the
So
variables?
okay, how do I know about this junction belongs to this not P?
No. The next line, like in the next, yeah. How did you know that there is a disjunction between the not Q and not Q? That's what I want to know.
Oh, how
Like
do I know that? Okay, so here, this negation of Q, I just pulled it down here, right?
Right.
And then this OR comes here with this negation of Q, right? This one here,
Okay.
it comes here,
Oh, okay. So you just move it. Okay.
right? So I just move things. So here, this and this here.
And then you just move
This,
that on the other side. Okay.
yeah.
Okay. Yeah. That's what I want to make sure. Okay.
I have a question.
Yes.
So how can you do it in a different way? Like from my own, I said negation of Q and Q was false. Then I now used like distributive law.
Which line are you talking about?
This the third line.
This one?
No, the one before that.
Here, this one?
Yeah.
Okay.
Then I said negation of Q and Q was false. Then I now used distribution law to assign it to negation of Q and negation of P. Then I started solving down. Can this be done that way? Can it be done that way?
So you are saying that, let me make some room here. So you are saying that it should be how?
Then I said negation of Q and negation of P.
And negation of P, okay.
Or false.
Or
False, yeah.
false?
Yeah. Can this be done that way or no?
Yeah, of course. So you're basically trying to simplify this, right? Negation of Q or negation of Q, right? So you're replacing this with false, right?
Yeah.
So here, yeah, it could be absolutely done in this way. So here, negation of Q and Q. So you're using this one here, right?
Yeah.
Negation loss here. Yeah. So of course it can be done that way either. Yeah.
Okay, thank you.
Yeah. So, but the eventual solution will be this truth, which is the most simplified solution that can be ever reached for this propositional statement. Okay, and here, if you guys might have noticed here, so this one was one of the trickiest part in this whole proposition. So if you know how to do this, so here this conjunction with the disjunction, so you have to open it up properly like this here, right? Because if you don't do this step, then your upcoming equivalences might not be correct, which might lead to a wrong answer. Okay, and then here we also saw that the order matters in which it goes. So here we cannot always just flip things up. So there are certain rules which you guys will be covering up really, really soon.
Okay. Yeah.
Any other questions? So let's take a last example for today's tutorial. So here we have this propositional statement over here, and then we are asked to write down the to determine if it is logically equivalent or not. So again, likewise, what we can do is we can either draw a truth table, or we can use the logically equivalence for these ones as well. So let's do it using the truth table this time. So here we have 2, so we won't be needing much rows. So maybe okay. So we have this B here, B here, we have this Q here, and then we have P, and then this is biconditional. So let's hit the symbol. Okay. P bike. Okay. Then we have the negation of this. All right, negation. P implies Q. Okay. And then we have negation of Q. Then we have basically it's going to be just the same thing, not too hard. So true, 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 false, false, true, false, false. Okay. So it's not going to be here. Let's remove this. Okay, so P, and then there is this biconditional statement. So let me just pull up the truth table for that for your reference. Okay. Okay, so we have this on the top. So here P biconditional with Q is true, true, false, false, and then here true, right? Okay, now we take the negation of this thing. So it's going to be false, it's going to be true, true, and then it's going to be false. So negation of Q, it's going to be false, false, true, and then true, right? So, and then here, so P implies, so we have to take this one. We have to take the negation Q.
Miss,
Yes.
the biconditional for the second row shouldn't it be true?
This
Since
one?
we have true. No, the fourth column.
This one?
No, the second and third row.
P and Q, true. It should be true, false for second row.
The second row here?
No, like for the P and Q, right? Like you were in like true, 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 true. It should be true, 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 false, false, true, false, false.
That's okay. Yeah.
Okay.
Okay, yeah, thank you guys. Okay, so here we have true, false, false, true as per the table here. Now we take the negation of this, going to be like here, and then negation of Q, it's going to be false. This is going to be true. This is going to be false. Okay. Now we have to take up P here. Then we have to take the biconditional of this one here. So true and false. So true and false is false, right? And then we have this true here, and then we have this true here. We have to take true. True is true. Okay. Now we have this false here, and then we have this false over here, right? False, false is true. False, false, false is true. Okay. We have this false, and then we have this true. So false, true is false. Okay. So using the truth table, we prove that this here, which is basically this one, negation, this side, and this one over here. So we prove that because their truth values matches, because the truth value matches, so we know that they are logically equivalent to each other. Questions? So some important takeaways from the tutorial are that you definitely need to know the truth tables and the equivalencies. There are some laws as well, which you will probably get used to once you have a lot of practice. And here we see that there is ordering that matters. So we have to be very careful when applying the rules and when moving forward. Always solve the things in the bracket first, and always solve the things in the order of precedence. So if you guys have any questions, you can ask me, or if you don't have any questions, then we can end today's tutorial. If you guys have any questions like you want me to solve, then you can email me as well, but you need to email me at least like 2 days before so that I can keep that in mind. Okay. Okay, so if there are no more questions, then we can end the tutorial here. So thank you guys, and I will see you in the next tutorial on Thursday, 5:30.
Yep. Okay.
All right. Thank you guys. Bye.
Bye.